3-1, domain and range of functions. So a function is a special type of mathematical relation in which each input value, x value, is paired up with exactly one output value, the y value. Functions can be represented as a list of ordered pairs, table of values, a mapping diagram, a graph, or real-world situation problem. Domain of a function is a set of all numbers that are possible as input values or x values for that function, also known as independent variables. Independent, as we're going to see later on. The range of a function is a set of all numbers that are possible as output values or y values for that function, also known as your dependent variables. The domain and range of a function can either be continuous or discrete. A discrete function is a function where the domain and range can only take on distinct separate values, meaning they can only be whole numbers. For example, the domain and range may only contain integers, but no fractions or decimals. Continuous is a function where the domain and range can be any number with a given interval. For example, the domain and range may contain integers, but can also be decimals or fractions within that interval. So here's an example of a continuous problem. When you're filling up a pool, you have the amount of time as your independent variable, and the volume, gallons of water inside the pool, would be your dependent variable. So the volume of water in the pool can be determined at any point in time for any value of x. So how much volume is in the pool depends on how much time it's being filled. So at 0 minutes, the pool is empty, 0 gallons. So that's why it starts at 0, 0. The smallest domain is 0. The smallest range is 0. Time, it takes up to 1,000 minutes to fill up a pool because x is going by 100 minutes and then it ends at 10. So 1,000 minutes, and then for every 1,000 gallons is my x, so it ends here at 10 times the pool is up to 10,000 gallons. So it can be, the reason why this is continuous is because you can find out how much water the pool has in 5.5 minutes, 2 3/4. So because your domain can involve fractions and decimals, that's what makes it continuous. Here they're talking about the number of tables and chairs in a restaurant. The number of tables and chairs must be whole numbers. For every 1 table, you need 4 chairs. 2 tables, 8 chairs. 3, 12. 4 tables, 16 chairs. So the domain, these numbers specifically have to be whole numbers. So you have to make a condition that x is an integer, and then it's any number greater than, you can write also x is greater than or equal to 1. And then y, since you're starting 4, 8, 12, you can write it as a condition that y is a multiple of 4. Domain and range can be written 2 different ways. One way is writing it as an inequality, like the ones you see in the continuous graph above, or it can be written in set builder notation as the discrete problem. They can also be written as a list of distinct numbers when the function is discrete. So here, writing it as an inequality, my smallest domain is -2. My biggest domain is 4. So from -2 all the way to 4. So my domain is -2 less than, because -2 is less than x, and x is less than 4. And because they are both closed circles, they have the equal sign. Range, all my numbers from -3 is my smallest range. 5 is my biggest range. So -3 is less than or equal to y, which is less than or equal to 5. It's going from -3 all the way to 5. And then writing it in set builder notation, It's a form of set notation that specifies a variable and conditions. So all values of x such that x is -2 is less than or equal to x, less than or equal to 4. My range, all values of y such that -3 is less than or equal to y, which is less than or equal to 5. So writing this in both inequalities and set builder notation. My domain for the first one here, -1 is my smallest x value, 3 is my biggest x. So -1, always smallest goes first, 3 should go last. Domain, talking about my x. So from -1 all the way to +3, -1 is less than x, and x is less than 3. Because they are open circles, there is no equal sign. And then writing it in set builder, all values of x such that -1 is less than x, less than 3. My range, -1 is my smallest y value, +1 is my biggest y value. So -1 is less than y, which is less than 1. Again, no equal sign, open circles. In set builder notation, all values of y such that -1 is less than y, less than 1. My domain here for the second one, smallest domain is -3, biggest domain is +2. -3, 2, domain, we're talking about my x value, from -3 all the way to +3. -3 is smaller than x, x is less than 2, closed circles, these do need the equal sign. Set builder notation, all values of x such that -3 is less than or equal to x, less than or equal to 2. My range, I'm going from -3, my smallest, +4, my largest range. So -3 is less than y, which is less than 4, both closed circles as well, also with the equal sign. All values of y such that -3 is less than or equal to y, less than or equal to 4. Now these all had a start and a finish, start and finish. This one has a start and it goes infinitely up forever. So this starts at 0, 1. So my domain here are all values of x that are greater than or equal to 0, or you can write it as 0 is less than or equal to x, less than or equal going up to the positive infinity. And then in set builder, all values of x such that x is greater than or equal to 0, or you can write the other one as well. My range, smallest range is now at 1, so y is greater than or equal to 1, or you can write it as 1 less than or equal to y, less than or equal to your positive infinities. In set builder, all values of y such that y is greater than or equal to 1. Next, 13, there is no start or finish. It is going up forever and down forever. This is a linear function and it has a positive slope, which means that my domain would be all real numbers. Writing it as an inequality, you can write it with the infinity symbols. Negative infinity is less than or equal to x, less than or equal to your positive infinities. Writing it in set builder notation, all values of x such that x is a real number. or you can write it with the infinity symbols, with your inequalities. My range also is going down forever on the y, going up forever on the y. So my range is also all real numbers. Negative infinity, less than or equal to y, less than or equal to positive infinity. And my range, all values of y such that y is a real number. This is now something that is discrete because there are certain points. So remember what it said earlier, that discrete can be written as just the set of domain and range. So my domain here would be -4, -2, 0, 2, and 4. If you are going to write it in set builder notation, this does have a condition. These are even integers, so x is an even integer. And now that you have stated the condition that the numbers are, now you can write it as an inequality. -4 is less than or equal to x, which is less than or equal to 4, because you know that they have to only be even integers from -4 to 4. Range, going from -1, 0, 1, 2, 3, writing it in set builder. These are only integers, so y is an integer. And then my condition is that they're integers, and then writing it with as an inequality, they're integers between -1 through 3. My domain, -4, -3, -2, -1, 0, and 1. Again, integers also. So x, all values of x, such that x is an integer. Sorry, going this way, -4, -3, -2, -1, 0, 1. And then -4 is less than or equal to x, less than or equal to, that's a 1 here. My range, bottom up, also -4, -3, -2, -1, 0, and 1. All values of y such that y is an integer. And our integers from -4 through +1. When given a real-world situation, you must first identify your independent variable and your dependent variable. Independent are your domain, your x values, your input. Dependent variables are your range, your y values, your output. Once you identify a variable, your independent and your dependent, think of the set of numbers that it could represent them. So for example, a car has a 15-gallon gas tank and gets a maximum average mile of 24 miles per gallon. My independent variable would be my gallons of gas. My dependent would be the miles that are being driven. What could be a reasonable domain? If I'm on empty, I have 0 gallons of gas, and the maximum that it can hold is 15 gallons of gas. So 0 less than or equal to x, less than or equal to 15, and this would be, I could just jump ahead now, and it can be continuous because you can have a decimal or a fraction of gallons of gas. So that's why it can be all numbers between 0 and 15. That is what makes it continuous. And then what can be a reasonable range? Well, if I have 0 gallons, I am going 0 miles. And it holds 24, you can go 24 miles per gallon. So the most I can go at a filled 15-gallon gas tank, 15 times 24 would be 360 miles. Kai invited 5 friends for a sporting event. Tickets are $40 each. He knows that at least one friend will go with him. So my independent variable would be number of tickets. Dependent variable would be the total cost of the tickets. Reasonable domain, the least amount of people that are going, him and at least one friend for sure. So 2 may go, 3, 4, 5, and if all friends, 5 friends go and him, would make it 6 people. So you can either write it like this, or as in set builder notation, all values of x such that x is an integer, and 2 is less than or equal to x, less than or equal to 6. Reasonable range would be multiples of 40. And then all values of y such that y is a multiple of 40. And then 40, the least amount of people going are 2, so 40 times 2 is 80, less than or equal to y. The most that is going is 6 times 40 would be 240. And then because domain is your number of tickets, 2, 3, 4, 5, that is what makes it discrete. A bowler plays $2.75 per bowling game they play. Independent would be number of tickets. Sorry, number of games played. Dependent would be total cost. So reasonable domain, x has to be an integer. And it could be x is greater than 0. 1 game, 2 games, 3 games. And then y is a multiple of $2.75. And then again, it has to do with your independent variable, number of games, 1 games, 2 games, 3 games. It would be discrete. Domain and range of mapping diagrams. This would be your x values, this would be your y values. So my domain would be 1, 2, 3, 4. So those are integers. So x is an integer. And they're integers between 1 and 4. So 1 is less than or equal to x, less than or equal to 4. And my range can only be the number 3. So all values of y such that y equals to 3. Letter B, the diagram shows parking fees for some vehicles at a local beach. Assume that the sample includes the minimum and maximum charges for parking. Describe any reasonable constraints on the domain and range. My domain are whole numbers. All values of x. X is an integer, or you can write whole number. And x is greater than or equal to 1. And then my range, since they are giving you money with 2 decimal places, all values of y such that y is a decimal. And then the minimum is 8, maximum is 16. So 8 is less than or equal to y, less than or equal to 16. And that is 3-1, domain and range.